Everyone, my name is Murki Kartikeya and I would like to introduce our project of fuel monitoring and theft detection system using IoT. Abstract. Fuel theft is an illegal act that involves stealing fuel from vehicles or storage facilities. With the rising fuel prices, this issue has become a growing problem. There are various methods employed by fuel thieves, including siphoning, drilling, burglary, and tampering with the fuel gauges. Among these, siphoning is the most commonly used method, where thieves use a hose to extract fuel from the vehicle's tank. They may suck on the hose or use a pump to facilitate the process, which can be done quickly and easily in a matter of minutes. Drilling is another frequently employed method, which involves creating a hole in the fuel tank to siphon out the fuel. Although this method takes more time compared to siphoning, it allows thieves to steal larger quantities of fuel at once. Burglary is a more destructive method where thieves break into a vehicle to directly access and steal fuel from the tank, potentially causing damage to the vehicle. Tampering with fuel gauges is also another method used by fuel thieves, whereby they manipulate the gauges to make it appear as if the tank is full when it's actually empty. This allows them to extract fuel without the knowledge of the owner of the liable fuel. Fuel theft has significant financial implications for businesses and individuals alike. Additionally, fuel theft during transit is a common occurrence, with reports suggesting that around 16% of the diesel filled in the trucks is stolen. This alone amounts to a theft of significant value each year. Addressing fuel theft requires proactive measures to prevent oneself from such crimes. One solution involves leveraging IoT technology, specifically using modules like GSM, GPS, and cloud computing. By implementing these technologies, we can work towards eradicating the problem of fuel theft. Existing systems. Traditional GSM-based fuel theft detection systems. Many detection systems throughout the time have used the GSM SIM technology to send alerts to the owners via SMS message. But the system can be easily tampered with as an SMS is purely dependent on the network settings available in the surrounding areas. This SMS system can also be tampered as but using various means of network jammers etc. In many cases, these GSM systems alone do not work properly and the theft becomes undetected. Traditional cloud theft detection systems. Many detection systems nowadays use Wi-Fi enabled modules to send and analyze data via cloud. This indeed enables us to access data remotely, but not having a second case option can be proven costly in many scenarios, where due to some errors, the model doesn't function properly. Many other systems do not provide fuel monitoring and fuel theft detection at the same time, unlike our module that does so, using an integrated source of cloud and GSM technology. Our proposal. We introduce a simple and efficient system that activates when the system is powered on. From here, the sensor placed in the fuel tank monitors the data constantly. If a change in the real-time data occurs, a signal is sent to the buzzer sensor, activating it, and a message is sent via the GSM architecture to a mobile via an SMS, and real-time data is sent to the cloud. This project is not just a fuel theft detection system, but also a system used to monitor fuel data and use the data to compute patterns and understand the activity. This data is also used to plan a trip as many of times we would need to refuel in between trips, and this data allows us to see whether a trip is possible or not. The system allows us to access previous records and data as we integrate it using ThinkSpeak. Sequence diagram. Sequence diagram is a visual representation of interactions between objects in a system. Here we can look at the sequence diagram of our project and understand it. Activity diagram. Activity diagram is yet another UML diagram we have represented. Activity diagram is a graphical representation of workflows or processes within a system. State machine diagram. State machine diagram illustrates the states and transitions of an object or a system. Here we can see that there are two states in our process, that is when it's powered off and powered on. Basis on the various values applied to it, the state of the program changes. Data flow diagram. It illustrates the flow of data within a system or a process. Here, the user turns on the power, which causes the system to causes the system to cause real-time data monitoring. This real-time data is sent to the microcontroller. If fuel theft occurs, then this data is sent to the SMS module in the handheld device. Else, real-time data is sent to the cloud. This cloud uses a database in order to store the data. The database gives access to the data, which can help us in data analysis. This data analysis data can be sent to the mobile app. System architecture. This gives us a general implementation and the architecture of our project. Here, we connect the project to the power supply. We use ultrasonic and float level sensors in order to detect data. This data is sent to the microcontroller. There are three actions here. No action, fuel theft is recognized, and real-time data transmission. When fuel theft is recognized, it is sent to the GSM module which uses GSM technology in order to send an SMS to the handheld or mobile device. When real-time data transmission occurs, it is sent to the cloud, which is used for data analysis, and this data can be accessed using the mobile app. Implementation. As we can see here, this is our system architecture design in real life. There are various sensors applicable over here. This would be the LCD sensor. This is the ultrasonic sensor. These are the buzzer sensors. This is a GSM module. This is the GPS module. This is the Arduino, which is used in order to connect various machines and sensors. As all the sensors do not require the same amount of voltage and power, and connecting it using the ESP module would cause it to damage. This is a power module which it takes the input and regulates the power flow. Next video shows the working process of a system. First, the power is supplied to the system. This initializes the system and and induces the LCD in order to show this starting of the signal. GPS signal is sent to the system via the GPS module, stating that the signal is ready to use. Now, we would like to show you different components which are GSM, ESP32, uh, buzzer sensor, GPS sensor, power module, and Arduino. We use an ultrasonic sensor to read the fuel levels in our system. Ultrasonic sensor is a sensor that consists of two ends, one for sending the signal and one for retrieving the signal. The signal is sent in the fuel system and it reflects back of the fuel level. The reflection signal is taken back into the ultrasonic sensor, and the distance between the ultrasonic sensor and the fuel level is detected. This distance is converted into fuel level. This fuel level can be clearly seen in the LCD present over here. After this fuel level is detected, it can be converted using data analysis into distance that shows how long we can plan a trip and how much time we can move on the same trip with the fuel. Case of fuel theft. If fuel theft occurs, a buzzer signal is generated at the user end, causing a singing noise. The outputs of our system. The first figure shows the fuel level and the distance we can travel with the remaining fuel. The second system shows the SMS message sent in the handheld device via the GSM module. As we can see, it shows the oil level is low and gives us the latitude and longitude coordinates, which are the GPS coordinates using the GPS module present inside our system. It also gives us a Google Map location, which allows us to easily access and easily understand where our vehicle location is along with the module. Storing real-time data in our project, we use ThinkSpeak. ThinkSpeak is a free application software which induces cloud and helps us track our real-time data. ThinkSpeak also helps us analyze data in various forms and machines. As we can see here, the real-time data is stored in the field 1 of the ThinkSpeak column, and corresponding entries are stored marking which entry has what value. This is the use of ThinkSpeak cloud technology in our server for real-time data. Finally, I would like to also introduce my other group members, B. Hanumantu and Ayushram. We all together would like to thank our project guide, J. Yamini Devi Ma'am, for helping us complete our project. Thank you.